Hello, ladies and gentlemen. Thank you for the possibility to come here and talk about our project. This is a project for the smaller boiler. So now we are in the smaller scale. We are down in 10 kilowatts here, or 15 kilowatts. So now it's smaller. This also means that we have to bear in mind that the amount of money for the improvements is also decreased as well. So the components that we have to use in this area is much cheaper components for this to work. But the project is about a smart boiler, or using the knowledge and the data that we can get from the boiler, get both feedbacks but also feed forward the information that we can use to optimize the combustion and reduce the emissions. My name is Morten Gotlieb and I'm from the Danish Tecnológico Institute, which is a not-for-profit institute in Denmark. We do both research, but we also have testing and development for companies as well. The outline of my presentation will be just to show you the aim and the scope of this project, and it's an ongoing project that we are developing right now. I would like to show you a bit about the process, what parameters have we looked into, but mainly it's focused on air and the fuel and how to get more data on this to improve the combustion. I will also show you a bit about the type of sensors that we have used. I would also like to introduce you to a load cycle test, which is more or less a new type of way of showing real-life measurements, but in the lab. So it's not real life, but it's closer to real life. Then it's very important for us to see what is actually the impact of the biomass and what's the impact of the boiler. Where can we actually improve in this area? And of course, I will show the results that we are able to present to you right now, but they're still ongoing project. And at the end, I will show a bit about the outlook and perspective. It's a nationally funded project that we're working on. It's funded by the Danish EPA. We have quite strict regulation in Denmark. We are below the new eco-design limits. We have a tighter legislation in Denmark, so it's very difficult for the boilers to be able to be on the market in Denmark. And this means that there's also being invested in development in this area. The project is a cooperation between the boiler manufacturer, NBE Production, and the Danish Tecnológico Institute, where I'm located. It's a research and development, so we are doing some research in the project, and the company NBE Production is doing the development. And the scope is to develop a smart boiler, or to develop a boiler that has lots of information able to be put into the control system of the boiler, and still maintaining a low cost of the boiler. That's very important for this company. So let's look more into the boiler system. So the current boiler, and this is already something that is working, is that you have a boiler. The idea is just to put the boiler outside in your shed, and then it should work out there. All the data will go into the cloud, and from the cloud it's able to communicate both with the customer, but it's also able to communicate with the installer, and actually also to the manufacturer itself. So if there's any problems, they can contact the boiler, and they can give advices from overseas actually. So this is installed on every boiler from this company. The data that it collects is into this system that is available online, and everybody can go in and see what does all the other boilers do in this from this manufacturer, but only the one that owns the boiler can change the settings, of course. And it combines all sorts of data from solar and from other heating sources or something like that. That's possible, and you'll also get alarms if your fuel hover is too low, or the boiler starts and stops all the time, and something like that. But the idea is to get even more information into the boiler and use this information to reduce the emissions. So right now this is just feedback for the customer, how is everything going, but we would like to improve the combustion as well. So the development phases in this project has been walking towards actual control of the air, not relying on the manufacturer of the air unit. He's just saying that this blower will provide you so much air if that much current is added to the blower. But we actually want to know exactly how much air is going through it at different cases, because you have a different system. You have a boiler, you install it on a bad chimney, then it changes how the blower fan will work. So we want to measure that. We also want to measure exactly how much fuel is added. We don't want to rely on a calibration of an auger, which changes all the time. So we want to know exactly what the mass is. And we want to develop the stove, or the stove, not the stove, but the boiler, for actual use in real life and not for type testing, because type testing demands quite strict regulations, but we don't only want to develop the boiler for that, we want it to work in the real life as well. To measure the airflow, we introduced a Venturi flow meter, which in this case is a very simple method. We use also measure the temperature, of course, and we measure the pressure difference over this area, and we've installed it inside this small blower fan, and you can see on this picture here that it's installed in this area over here. So the component is very small, and you see it's actually just a plastic thing, but it's quite reliable, and it gives good enough results for this type of product. And it has showed quite good results, actually. I'll come back to that later. If we look at what the auger actually delivers, this is a couple of pictures where you can see the low parts. It should actually, where we are looking at the low pictures, it should actually be sending the same amount of fuel. So, but you see it's from 3 pellets up to maybe 50 pellets that is in this area. So how much mass of fuel is actually coming in? We don't know. And we can also see that the nominal load, the lowest amount there, is smaller than the low load. So what can we actually do here? And that's also based on the bulk density and the length of the pellets, and things of that changes a lot. So we wanted to be free of that. And we actually found that we could use a very simple technique with an acoustic technique for this. Actually just adding a microphone to a metal plate, but it works. So this means that we get signals that is showing different sizes according to how much mass we are actually delivering. So the Venturi has already been added now, but the acoustic system is going into the next model we are going to make, and we are looking very much forward to seeing those results as well. But the initial results show that we can actually see a difference on how much mass is coming. So that will make a great impact. See here. Why is it relevant to look for a load cycle test instead of just the 30%, which the 30% and the 100%? It is because this is actual data from the spring on I don't know, 6 different Danish boilers, and it goes all the way around. It's not 30%. It starts, it stops, it does every sorts of things, and it's different on different applications. Do you have the heat storage? How big is the heat storage and everything? If you look at the summer, it's more or less still. Only when people come home, maybe take a shower or something, and in the fall it comes more into pace, looks a bit more like the spring. And then when we come into wintertime, we actually see that we have some kind of use, but we are not at 100% even though here. So we need to be able to have our system work for these changing situations as well. So that's why it's interesting. The initial load cycle test that we performed was 24 hours of testing, and we included 4 seasons in this, but we could just see we are not stressing the boiler hard enough. We need to look more into the different seasons and saying we will make a specific test for each season. So now the next step will be to do 24 hours testing for each season, creating a test here that will be able to apply for all boilers that can actually test for this afterwards, seeing are we able to perform in real life. And it will be the spring and fall will be combined, and we will combine the summer and winter as well. This will really put the stress test of the system, and we will get realistic test of system performance. I will also show you a bit of the results. So this is about looking what is the influence of the fuel and what is the influence of the boiler. This is just a schematic of, I don't know, 5-6 different types of biomass pellets that we have used, and we have used there's both the prefix S is for that we have used scamol or vermouthkhalid in the boiler, and we have used ceramics to see does that make an influence, and it doesn't really make any difference with that. The real difference comes with the B pellet. That's an 8 millimeter pellet that is quite normal in Denmark for 8 millimeter pellets, but it's not good for this boiler. It was really bad for that boiler, so you shouldn't ever use that. And hardwood is the D pellet as well. It has also have difficulties with that, so it's also some advice that they should add to their products. But it's also to see more into what is the possibilities for reduction. And if you look into the NOx, there's quite a nice correlation between, we know that of course, but it means that when we do this correlation with this boiler, we can see what is actually the reduction possibilities for us regarding the NOx that we are creating with the combustion itself, and not what is a part of the biomass itself. We also wanted to see if we could not just look at the dust, not look at the specific content of the dust, but there's no real correlation. So we will need to analyze these final the salts and the minerals inside. There will not be an easy step here. We'll have to do the long haul. Then we did a test here. We just wanted here we included the air mass measurement into this boiler. The one we are seeing now is the original boiler without this one in, and the green one we are seeing is the draught of the chimney system. We are changing that because we want to stress this air measuring unit and want to see the function of that. So we are changing the draft from 25 down to below 2-3 Pascal. So it's really changing a lot over 24 hours. And the red one is CO, so this is just a simple comparison of what is happening when we introduce this air measurement, and we see that the reduction in CO is quite dramatically, and if we look more into detail and we look into the OGC or the tar content of the combustion, we also see a real reduction of these elements. And if we look at it into percentages, it's about 50% for CO and about 60% for OGC. And that is for a stress test where we are really pushing the boiler system as well. And it's actually producing quite nice results, even though it's such a difficult test that we are introducing to it. So yeah, it will definitely be interesting. Also, the next part will be to also add the measurement of the fuel and be able to get these two values much closer and do the optimization here. As I said before, we introduced this Venturi flow meter inside the blower fan, but we also, in order to do some kind of, we would like to get the more homogeneous amount of pellets out. So we actually also have been installed an extra auger inside the burner. So it is distributing the pellets more evenly. So even though there's smaller amounts coming in or bigger amounts, it evens it out a bit. And that has given a more homogeneous amount of pellets to the burner, so that helps a bit, but we still want to know what is the exact amount of mass so that we are able to really adapt the amount of air and ensuring that we are not pushing the air too fast or too hard through the fire and emitting lots of these ash particles. And there will definitely be a further reduction potential exactly by combining these two measurements. And the next part will also be to optimize the controller by this load cycle testing. So we will have the control system functioning on all these different changes, and how should that be optimized for the best. And then we will take a look of the air staging and the adaptation of air in these different load operations, with special focus on the NOx and the dust emission, because that is what we are having problems with in Denmark right now. Yeah, the outlook and the perspective from this smart boiler is that we will have improved emissions during real life emissions. So that is, yeah, we have the type testing that shows us one result. We know all from the automotive industry that we are now looking for real driving emissions. That is what we want to see. And in Denmark, it's very important for us as well to see real emissions from stoves and boilers, because that is what we breathe. So, and that is what we are actually seeing. So we will look more into that. It will also be able to give more feedback. So that's where this 4.0 both comes in for the control system, but also for the end user. It gives both them some details, but also the control system. It will be able to give a more active customer service. They can tell you there's something wrong with your boiler. You need to look into it. You need to clean it. You need to maybe change your flue system because it's not good enough. Our boiler is not able to blow enough air through it because your chimney system is too bad. And it will also be able to tell you some feedback on how to use your heating system. It can see that it's not functioning. Probably we need to start the boiler all the time. You need to install a heat source or something like that. The great thing about the system is that everything is in the cloud. So both the information but also the control system is there. So it means that new optimized algorithm can be placed directly into the boiler and it will be changed immediately. And that's so that means that works for every boiler on the market. It will get the new features. And it can suggest overall system performances of the heating of the house. And a next thing could also be, it's for the pellet producer, but it could be direct ordering of the fuel. The fuel hopper is too low, I don't have any more, give me some more, send it to my address, I'm ready. So it will be very interesting to see what these next results can show us, and we are really hoping that we can get very low emissions in Denmark with this project. Thank you. Gracias.
Yes, I was